Dear students, one of the shortcomings of an arch Q model is we have to estimate a lot of parameters. Specifically, we have to estimate Q plus 1 parameters. And when Q becomes very large, it consumes a lot of degrees of freedom. So the precision of the estimator will decrease. So an alternative to arch Q is suggested by Bollerslave in 1986. Arch was originally introduced by Angel in 1982. Bollerslave introduced an alternative known as GARCH. Generalized autoregressive conditional heteroscedasticity. GARCH has the advantage that it will capture longer lags with fewer parameters. A GARCH 1-1 model is written as HT is equal to delta plus alpha 1 ut minus 1 square plus beta 1 h t minus 1. It is the GARCH 1-1 model and it is a generalization of arch Q. Now, actually, this beta 1 ht minus 1 term captures all the terms other than ut minus 1. So we have to estimate only three parameters, delta, alpha 1 and beta 1. It is a generalization of GARCH model because this can be derived from this. This GARCH 1-1 model can be derived from arch Q. Here you have to estimate Q plus 1 parameters, whereas here you have to estimate only 3 parameters. It will not consume much degrees of freedom. It was introduced by Bollerslave in 1986. Now let us see how we derive this from this. Now, this is our HT. So H t minus 1 is equal to delta plus alpha 1 ut minus 2 square plus beta 1 h t minus 2. And h t minus 2 is equal to delta plus alpha 1 ut minus 3 square plus beta 1 h t minus 2. It is a kind of substitution which we are doing. So, HT can be written as delta plus alpha 1 u t minus 1 square plus beta 1 ht minus 1 delta plus alpha 1 ut minus 2 square plus beta 1 ht minus 2 is equal to delta plus alpha 1 ut minus 1 square plus beta 1 delta plus beta 1 alpha 1 ut minus 2 square plus beta 1 square ht minus 2. Now, this can be written as delta plus alpha 1 into ut minus 1 square plus beta 1 delta plus beta 1 alpha 1 ut minus 2 square plus beta 1 square into delta plus alpha 1 ut minus 3 square plus beta 1 h t minus 3 h t minus 3 is equal to delta plus alpha 1 ut minus 1 square plus beta 1 delta plus beta 1 alpha 1 ut minus 2 square plus beta 1 square delta plus beta 1 square alpha 1 ut minus 3 square plus beta 1 cube h t minus 3. And this can be written as delta plus beta 1 delta plus beta 1 square delta plus beta 1 delta plus beta 1 square delta plus alpha 1 ut minus 1 square plus beta 1 alpha 1 ut minus 1 square plus beta 1 alpha 1 ut minus 2 square plus beta 1 square alpha 1 ut minus 3 square plus beta 1 cube h t minus 3, and substitute the value of h t minus 3 like that. It will give you h t as equal to delta into 1 plus beta 1 plus beta 1 square plus alpha 1 into these terms ut minus 1 square plus beta 1 ut minus 2 square plus beta 1 square ut minus 3 square plus etc. This is an infinite GP. Delta by 1 minus beta 1 plus alpha 1 sigma j is equal to 1 to infinity beta 1 j minus 1 u t minus j square. Ht is, this is, now you can see this is the constant alpha 0 we have introduced earlier. Then the next term was alpha 1 ut minus 1 square. If you give the value of what to say j is equal to 1, then alpha 1 means 0, beta 1, j is equal to 1, that means beta 1 raised to 0, so 0, that is 1, then ut minus 1 square, ut minus 1 square. If j is equal to 2, it becomes alpha 1 into beta 1, alpha 1 into beta 1, then ut minus 2 square, etc. Parameters changes, but the point is ht is now a function of ut minus 1 square, ut minus 3 square, ut minus etc., ut minus q square. So ht is equal to, we can write it as alpha 0 plus alpha 1 ut minus 1 square plus alpha 1 t minus 1 square beta 1 ht minus 1, and it is nothing but, we can say, a reparameterization of arch q. That is, GARCH 11 is a reparameterization of arch q, where GARCH 11 is ht is equal to alpha 0 plus alpha 1 ut minus 1 square plus beta 1 h t minus 1. And by substitution, you will get it, and ht is a function of ut minus 1 square, ut minus 2 square, ut minus 3 square, etc., etc. So this is more parsimonious in the sense that we can estimate a GARCH 1-1 with the 3 parameters instead of estimating an arch q with the q plus 1 parameters. We also require that alpha 1 plus beta 1 is less than 1. This is a condition for what is known as stationarity. If it is greater than or equal to 1, then it will become what is known as integrated GARCH or EGARCH. Integrated GARCH. Integrated GARCH. And GARCH 1-1 has been extensively used in empirical analysis because it fits well to many GARCH processes. It says that volatility changes with the ut minus 1 square, and also it depends on ht minus 1, and beta 1 is a measure of the persistence. That is, it is a measure of the persistence because it represents all the terms other than ut minus 1, as you can see here. That is why GARCH 1-1 is very popular. And also, another reason for its popularity is that it is very easy to estimate because you have to estimate only 3 parameters instead of q plus 1 parameters. Now, using the same data we have discussed earlier. This r hat t is equal to 1.049, h hat t is equal to 0.409 plus 0.492, u hat t minus 1 plus 0.238, h hat t minus 1. Both the t values are significant, and also adding these together is less than 1, and all the parameters are greater than 0. So we will say that the conditional heteroscedasticity is GARCH 1-1. GARCH 1-1. And this is Boler-Slave model, GARCH 1-1, extensively used in empirical analysis. And this is one way of deriving the model. Another method is, in the arch q process, we impose a restriction alpha s as equal to alpha 1 beta 1 s minus 1, as we did in the case of Coyek model. That is, you write an arch q model, impose the restriction in the coefficients, you will again get this model. Both are, so you can practice it yourself. Only from a theoretical point of view, otherwise it is okay. This is the model, and remember this GARCH 1-1 is a way of converting arch q with a few number of parameters. And this GARCH 1-1 can also be generalized into GARCH PQ. GARCH PQ. So this is the second model. The first is arch q, not used extensively. The second is GARCH model 1-1 PQ, like that. You have to experiment with the different models. That is all.